My name's Hugh Blair and I'm from Massey University, and I presume by now you know you're here to hear about skin thickness, or have you got a thick enough skin? It's out of the PhD by Masood, and he's come from Iran to work with us, and this happens a lot at university. We've got a lot of international students who do this exciting research, pretty important. And Rao and myself are the supervisors. The work has been funded by Massey University and by the TRIG group. So the TRIG group, I'll be showing you a lot of data in a bit, that all of that information was paid for at their own expense. So nobody else has contributed to this work so far. I think you're all aware that lamb survival has a low heritability. If it didn't, we wouldn't be here having this discussion today, because we would already have fixed it. Part of the problem is that lamb survival is made up of a bunch of different traits. Sometimes if we can get one of these component traits that has a bit of genetic variation in it, it's correlated with the trait of interest, lamb survival in this particular case, and it's easy to measure, then we might be better off by selecting for that component trait. And that's what we were setting out to look at. So we're looking at skin thickness. That's the whole purpose of today. Here's an ultrasonic slide, which probably most of you know all about. Here's the eye muscle depth. Here's the bit of fat here and the skin sitting on top. If we look at a biopsy from that, we can see, I haven't got the eye muscle, which is down below here. So here's the fat level that shows up with these orange globules. And then we've got the skin thickness here, which is made up of the dermis and the epidermis. Right. So what we had from TRIG was that we had about 24,000 records. You can see that here, and we had it for survival, for skin thickness, for fat depth, eye muscle depth, weaning weight and fleece weight. You can see the number of records is not always that high. Over here we've got the range of values, and so unsurprisingly survival goes from 0 to 1. But this is the one of interest, is that skin thickness is varying from 1.5 mils. So, you know, if you think of 1.5 mils, you can hardly hold your fingers apart at 1.5 mil, but going out to 5 mil. So we've got a reasonable amount of variation, this 17% variation in the mean here. So the important thing in this slide is that it looks like we have some variation in skin thickness to play with. On the next slide, we're looking at the genetic parameters. So this column here, the heritability, so we already know this, the heritability for survival is low, near enough to 0, but importantly, skin thickness looks like it's got a reasonable level of genetic variation, somewhere around about 0.3. And these values here for the other traits sit around about where you would expect them to be. Now, this has not been shown before. This has not been published anywhere. This is the genetic correlation between skin thickness and survival at weaning. So the first thing is, it's moderately positive. So if we have a thicker skin, that's saying that survival is going to be higher. We're also going to have a greater fat depth, and that'll come back in a minute. But we have got these two negatives here, which we've got to be just a little bit cautious with in eye muscle depth and weaning weight. But nothing too serious. It's nothing that selection index can't take account of. If we look at the literature that is available to us, there is not a lot. So as far as sheep are concerned, they're in merinos and they're using calipers. So calipers are the things that pinch your skin, and you measure basically twice the skin thickness. And not particularly new, 1982, 1991. And they are getting values somewhere around about the level that we were showing. So sort of a 0.3-ish, a moderate type of heritability. And there's one value there in cattle that I found. These two correlations I thought are important. So back in the 70s and 80s, John Slee at Edinburgh, he did a selection for cold tolerance. So what is that? What he did was that he basically exposed the lambs soon after birth to water and a fan. So he was trying to emulate what it would be like out on the Scottish Highlands with wind blowing and a bit of rain. Those animals whose rectal temperature did not decline all that much were considered to be cold tolerant. And then he selected those animals as the mothers and fathers of the next generation. So he showed after several generations that those animals that were cold tolerant had thicker skins. So that's good. That works in our favour. There was another selection experiment down here with the Coopworth lines, the fat and lean Coopworth lines. The fat line had increased survival compared with the lean line, and also had thicker skin. So all of this is sort of adding up to being looking positive, if you like. The quantitative values sort of line up with the correlations that we're seeing in other experiments. So what we then said was, okay, well, somebody's actually got to try this. If you had a thick skin group and a thin skin group, what would happen as far as their heat production and the heat loss is concerned? So what we did is that we generated two groups. So we looked at about, it was between 300 and 400 lambs. So we had our normal distribution for skin thickness, and we took the ends. We just took those with thin skin and those with the thick skin because we wanted to maximise our chance of finding a difference. We measured the heat production by basically measuring the amount of oxygen they consumed, and we measured the heat lost from those animals using an infrared gun, just like the guys do in the fire service. And then we looked at the thermoregulation. So here's our two groups. Here's our thin skin group and our thick skin group. Males and females are in there. Singles and twins are in there. There were differences, so in our analysis we took that into account. We got about 1 millimetre difference between those two groups off the end of the distribution. We got 1 millimetre difference between the means, 2.1 versus 3.2, and there was also a difference in birth weight, which again we accounted for in the analysis. The other thing we did was that we said, right, we're measuring at birth, but you guys are measuring out here at 6 and 7 months of age. So the first thing is that we said, right, at 1 month of age, what was the correlation? Near enough to 0. What's the correlation at 0 and 2 months of age? Near enough to 0. Slightly negative, it's real going bad. 0. At this stage, I'm going to jump off the building. At 5 months of age, 0.2, oh, okay. And then finally, at 6, 7, 8 months of age, we finally got a correlation back. So what this is telling us is that you've got to be very careful where you're doing, if you're already doing skin thickness measurements and you're using it at the time you do ultrasound scanning for fat depth or for eye muscle area, that time around 6 to 8 months is probably okay. But if you go in this range here for some reason, when we were not getting a strong correlation. The numbers in the upper part here are just the numbers at each of the measurements, and they range between 90 and about 70. If we look at the 5, 6, 7, 8 months of age, we get quite a nice correlation. So when you're out doing the ultrasound measurements at those older ages, the skin thickness is actually lining up pretty well. So that's a caution there. We've got to be careful. So now we're moving into measuring the amount of heat that comes off the animal. So we're using the gun, the infrared gun. There's 2 lambs in here. Here's one head. There's an ear there, an ear there, and it's got bent, and we're looking down on top. So this is the back of the animal, and this is where we're measuring. Here's the other animal. There's an ear there, head, and the back coming down here, and we're measuring that space there. So we're measuring the amount of heat that's coming off those animals, and as it is in most situations, red is a lot of heat coming out. Cold, green or blue is cold, which is around the head where there's not so many blood vessels. So here's our first result. What do we got here? This is the heat that's being thrown off from the skin. We started off in a room. This is springtime, so these animals are only a day old, remember, so this is September-ish. So the room temperature was only 13 degrees. What we then did is that we exposed the lambs to increasing levels of wind speed, fan, and water being sprinkled on their back. So a little bit, a bit more, and a bit more. And so the red line here is our thin-skinned animals, and so what this is saying is that they are letting off more heat. Now what we've got is the amount of heat production. So same situation, baseline, and then we've got increasing amounts of water and airflow. So those animals that have got thin skins are also producing more heat, which is probably unsurprising. We just said in the previous picture, here they're losing more heat. So it's pretty unsurprising that they're also producing more heat because they're trying to stay thermoneutral. They're trying to keep their body temperature constant. So those two graphs go together pretty nicely. So this is what I think we know at the moment. So skin thickness and all the evidence that we've got available is saying that it's somewhere around about moderately heritable. So we've got useful genetic variation. It's positively correlated with lamb survival, at least again the information that we've got available. This is the caution. Remember that the day 0 correlation with out to about 5 months of age, the correlation is not strong, but it comes back 6, 7, 8.
Who
And the final point, which I think is the killer, this is what it's all about, is that the thicker skin reduces heat loss and it reduces heat production. So what do we need to do? Well, this is only a pilot study, remember, and most of the questions that you're going to ask me, I'm not going to be able to answer because it's a pilot study. Are the heritabilities and correlations similar in different breeds? We've got a study running now, I think. It's August with Focus Genetics. So thanks very much to Danny and her team for letting us loose on the flocks. We need to confirm that skin thickness works in more than just this one study that we've done, and particularly under field conditions. We've done nothing about brown fat, which is obviously, well, not obviously, but it's so important for heat production. It's the shivering fat that animals use to keep their body temperature up. Associated possibly with that is what options have we got as far as genomic selection is concerned. Massey has picked up, I think, 5 candidate genes, but we haven't looked at the results yet, so that's still coming. And most importantly to me, I think, is have we got any unintended consequences here? Because if the lambs would have been dying for the last 100 years or whatever, you would think that all the thin-skinned ones would already have gone and we're only left with the ones that were able to breed. So maybe there's some stabilising selection happening such as, so for example, do the thicker skinned animals get heat stress in the summertime and therefore they can't breed as well? I mean, I don't know, I'm just putting these up there. And we've also got to be aware that we could reduce weaning weight and the eye muscle area. So the final point from me is, as I said when there was a break before, is that what I want to know from you, is there any interest that we push this along? It doesn't have to be just a Massey University thing. There's so much to be done. We're going to need a lot of people to work in the area. The major challenge is getting funding at the moment. Through the government funding agencies, or at least through MB, there's really not any particular interest in funding production related research. So, open for questions.
How does this work relate to the cold tolerance test that Lincoln University provides?
Yep.
Is it the same gene? Are they looking at skin thickness, or what's their cold tolerance?
So the one that John Hickford has got, that actually came out of the study from John Slee at Edinburgh. So John Slee published the result back in the 80s that it was noradrenaline was the gene that was involved, and so that's what John picked up here. So absolutely, we're not working with Lincoln as such because the information's in the public arena and it's one of the genes that we've incorporated.
So we're looking at a completely different mechanism to what John's looking at?
No, not necessarily. With a bit of luck, you know, we're sort of hoping that in the thin-skinned group we'll get one of the alleles, and in the thick-skinned we'll get a preponderance of the other. But until we do the work, we won't know.
I mean, will you work with him? I mean if you spend $1 million over 5 years and find that his cold tolerance gene test is the best way to go, and it's a long time, a lot of money.
Absolutely. I mean, I'm not going to make money out of this. This is just for New Zealand Inc. And so what we've got to do is, my view is that lamb survival is on the radar. Well, put it the other way, lamb deaths are on the radar, and we only need to get into an ugly event on social media and we've got a problem. So I think we've got to show as New Zealand Inc. that we're doing stuff, that we're actually trying to make progress.
Is that not a counterlever to the productivity issue?
What do you mean, Richard?
You're saying MB's not interested in productivity bids and bids that incrementally boost productivity.
Well, last time around they didn't fund any.
No. Okay, but no, but don't go into that band. Go into the
welfare.
Sure. Well, I actually think the easier route to go is that if BLG is prepared to come to the party in some way to give us some little bit of funding, I think if we go to the Sustainable Farming Fund and probably AgMart, I think that's probably a lower hurdle in the first instance. And then we've got more information.
Is the funding pool big enough? Is the funding pool big enough? Is it?
Well, I think the Sustainable Farming Fund is in the low 100,000s. Yeah.
This fits in nicely with the message you given this morning. What we want to see from breeders, commercial products, animal welfare, and that fits nicely.
Yeah. So, but in answer to the question down the back, would I work? I would work with anyone. I don't have a problem working with John or with Tricia or whoever it is. It's not a problem.
Are you needing breeders to volunteer anything? Like you wanting data or stuff?
Well, one of the options is, I think, because part of the problem is that, say for example, I wanted to go to Callaghan. I'm not a taxpayer. Well, I am a taxpayer, but not a taxpayer in the sense of the way in which research would be used. And I've been with Ross, who unfortunately is not in this session, but he was in an earlier session, and we tried to go to Callaghan, and because he was one taxpayer, they weren't interested. But I know that there have been other groups where they've got groups of farming, they've got a structure, so you've got a chairman, and you've got a board, and then you've got a whole bunch of other people, and all of a sudden they take notice. And they say, oh, I didn't realise that it was that important to the farming community. So that to me would be where initially the backing would come from, is that we want the farmers to be in behind the bid, and so we might want letters from people to say, yep, this is the most important.
But in terms of your research, I mean, are you wondering other ways we can measure skin thickness and
absolutely
provide with the
We
data?
will start recording it when we did IMAS with scanning, ensure that we've got a lot of data we give you.
yes, yep. So all of that.
I mean, not all scanners can measure
No,
skin thickness.
no,
Some
that's
of them
right.
are pretty old screens.
And if we're doing it at age group 2 and 3 or 4 months,
We're
there's no
struggling.
correlation.
Probably 6 months minimum. Which ours would be.
So can you measure on a birth
Then
if
actually
you're doing
going
it
to
now?
go to all the things that actually affect these
Wouldn't that,
things,
because wouldn't the things come until die possibly?
Sure.
cause
So
that
it's,
to die?
we've really got to start from now, because if we're looking at skin thickness at birth, nobody's done it apart from us. So we're going to have to start now with a clean slate and say, right, if we look at skin thickness at birth, we're probably already too late for the current season, right? So we've got to be planning for 2019. We've already got a lot of people who are doing the 6 to 8 month, and that's what we're doing the focus this season right at the moment. And that's really just putting a check on what we've already done with the trig group is actually looking about the same. I don't think that's a big danger. I think we'll tick that box fairly quickly. It's really to go to the next step.
How would we measure it at birth?
Sorry?
How would we measure it at birth?
How?
Yeah.
Yeah, so that is the big question. You know, I'm not going to ask all farmers to go out at 24 hours and measure the skin thickness. It's done.
Well, we're tagging ours at birth. I mean, close enough to birth.
Yeah, so we've talked about, is it time to go, is it?
The buses are arriving.
So we've talked about whether so one of the bits we've got to look at is the tail. So can we get the tails and get the skin thickness off the tail, and that correlates with the rest of it. Anyway, thanks very much for your attention and your interest. I think we'll be continuing.